Welcome to the next lecture, which is on interior illumination. This one we're going to start with chapter 14, which talks about light control. And one of the things that is probably the gateway to discussion of light control is to understand that different surfaces have different characteristics in regard to how they respond to light. One is for opaque surfaces, which is on the left, and the three ways that the view depicts. One is a specular reflection. Specular basically is another word for reflective, so a specular reflection would be purely a mirror. Then there's semi-specular, and this kind of correlates to somewhat matte, more matte surfaces. And then completely matte surfaces have diffuse reflection. So the light hits it and it actually kind of spreads all around. As opposed to a specular reflection where the light hits the surface and it basically bounces away at exactly the same angle. Now, when you think of translucent materials, which is on the right, and this is anything from glass through to things like 3-form, then you'll get some direct transmission, but there usually is some kind of reflection. Okay. And again, you can have a surface that is completely glossy, somewhat transparent, and this might be akin to a fritted or sandblasted type of glass, to a fully fritted, very soft surface. And that diffuse transmission that you get through that surface can be really good if you want to spread out, say, a bright light source to make it a little less glary. And one of the sort of physics elements that you have to understand is that the angle of reflection and angle of refraction are very important. Reflection is when light is bounced off a surface. And with that, the angle of incidence is equal to the angle of reflection. So if a light hits a surface, a reflective surface at, say, 30 degrees, it will bounce off in an equal and opposite direction. So it will bounce away at 30 degrees. Refraction bends the light. And this is the effect where, say, you're looking in a pool and you see a fish and you reach to grab it, but of course it's not where you think it is. It's because the light has refracted. It has bent. And this is super complicated and has to do with the surface tension and stuff like this. But the only thing you need to know is this is how lenses work. So when you take a look at a lens, it works using refraction. Light bends going through these translucent materials. And you can use that there, for example, an architectural type of light. You can use it to either spread a light source or angle it. And an example of that is something like a lighthouse light, which has these sort of massive glass lenses that focus light very far away. Anyway, the other thing is by taking care to figure out the angle of incidence and angle of reflection, you can design light fixtures that take advantage of that. This is a parabolic reflector, and what happens is when you have a single light source, because of the unique shape of this parabola, all light is reflected at exactly the same angle. It all comes out of these at the same. This is really great for something like a downlight. You can also use it, this is a parabolic troffer, a fluorescent fixture, and once again the light source reflects and it all goes at the same angle. In this case, you're trying to reduce the glare of the light fixture by spreading the light at an angle. That angle reduces glare on surfaces below. So, and then here's some nicer diagrams with some actual examples of light fixtures. Again, the complex shape of the reflector and the fact that this is a single bright source means that you can control exactly how the light comes out of the fixture. And there's a million variations on these, and of course they are somewhat based in the old style light fixtures, which are based on a single light source. In this case, there's a special reflector over here called a kicker reflector. And the kicker reflector sends light right along the wall. Whereas see how here there is an angle where the light is kind of cut off. Here they're trying to wash this wall by kicking light out vertically. And again, it's just using the geometry and these funny little puckery things. So anyway, and then you also have adjustable lights. This is a pure wall washer. The previous one has a downlighting feature. This one you can see all the light is going sideways, very close to the top of the ceiling. And again, using a very specific kind of light source. Now, every light source, one of the things you have to worry about is shielding it so that you don't have too much glare. There are a number of different types of shields. I guess the terminology can get a little confusing, but a baffle is basically a single shield, something that you use to block a light source. A louver is a series of baffles. Cowls are another thing that you typically see on like track fixtures, and then shades, again, window shades or light shades we're very familiar with. And there's a number of different features of each of these. Just the one thing you need to be aware of, and this is particularly true when you have something like a fluorescent fixture, you really do want to control that glare, but you do lose efficiency in the light fixture, okay? And what I think a lot of you might see if you are driving around, New England has been replacing their street lights bit by bit with LED light sources. They are quite glary unless you live in a rich town. The unfortunate factor is that they just aren't using proper shielding on those fixtures. But one of the reasons I think they aren't is because of the reduced efficiency of the fixtures. Alas, I think that's a miscalculation. But anyway, just some diagrams from the book. Again, a pretty simple idea. Wherever your eye is, which is down here, there is some angle at which the light source is shielded. In this case, the light can still go down from these fixtures. And just a 3D view. Again, baffles are repeated. And then something like this, which is what's called a barn door fixture. These are adjustable typically, and you can cut off the angle at which the light arrives on a surface, and these are quite adjustable. Obviously, they're more theatrical in use. And then you see a million different types of clip-on glass lenses. And again, these take advantage of the properties of light, but also take advantage of the ability to add color. Now, of course, nowadays we don't need to worry about color quite so much because we can use LEDs that are color adjustable. But you can certainly use these clip-ons. So anyway, so that's pretty much it for light sources. For luminaires, so let's talk about how those are configured. First of all, typically you identify louvers by what they do and then how they are mounted. So there's a couple different kinds of mounting, and again, you may see these, have seen these around. Recessed lighting is probably the most common in terms of raw number, but obviously they're the least apparent because they're recessed. Surface mounted is, as you might imagine, it's something that's glued onto a surface somehow, something like a wall sconce. Suspended, which is otherwise known as pendant mounted. And then there are light sources that are called, I don't know, architectural is one word, coves, valences, slots, built-in type of lighting. So let's take a look at some of those. Oh, before we do, all lighting in the United States needs to have what's called a UL label, Underwriters Laboratories. And if you design some sort of custom fixture, that's going to have one too. So anyway, as for the light distribution of the luminaires, of course, this is a design consideration. Where do you want the light to go? But then you also want to decide, the aesthetics of that, and then choose a fixture that matches both the aesthetics and the distribution of light. Now, what I'm talking about here is, so every kind of luminaire you could draw a candela distribution curve that describes how much of the light is going down and how much is going up. So, for example, an uplight typically has all up, 100% up. But this one here is a suspended luminaire. It's mostly a downlight, but there is a small amount of uplight. And these polar candela distribution curves, you can see any number of them. This is all up. That one was all down, and then this has a little up and a little down. And these are lovingly known as direct, indirect filter light fixtures, which are, it's a little passive aggressive if you ask me. But anyway, the idea is that there are any number of different flavors of directionality of the light fixtures, and it's really up to you as to the effect you want to have. If you want a little lighting on the ceiling just to create a sense of volume, you'll want a little uplight. But sometimes you want much more uplight and less downlight if you have, say, a lot of screens in a space. Conversely, if you have a lot of visual tasks that are flat, like reading or assembling, I don't know, boards, then you're going to want more downlight. So anyway, and then each luminaire can have a distribution curve. This is a wall washer. All the light is going sideways. And if you remember the calculations lecture, we also looked at the sort of IES graphics, IES file graphics that show a three-dimensional distribution of these polar candela curves. You absolutely can get those for luminaires as well. So anyway, let's take a look at some actual fixtures now. First of all, downlights. There's a number of different ways people have referred to them: recessed cans, hi-hats. And these are very common. Typically, they're finished in aluminum, but you can get them finished in any number of ways. Back in the old days, these were meant to house good old incandescent lights. This is an example of a semi-recessed fixture. See how it sits on a junction box. Everything is kind of screwed together, and there's a base. There's obviously a dimension for the housing that is, mainly determined by the light source and the reflector. The interior diameter here is the aperture. That's the opening. Good word to know. And then this outer diameter is the sort of ring or cover. And again, these vary ridiculously by the number of types of fixture. And so, here's something that is sort of semi-recessed. There's a junction box recessed into the ceiling. This one, the junction box is actually mounted on the ceiling. Okay, just gives it a little more spacing. And then here's one where they've actually got a little metal rod that is attached to a junction box. Again, anytime you have built-in lighting, or if you're designing a custom light fixture for, say, the IES-NE competition, you're going to really want to think through how are you mounting these fixtures. Okay. Anyway, and there's so many different flavors of recessed lighting depending on the light source. This is a very low glare fixture that uses what's called a silver bowl lamp. And this is a compact fluorescent one. So again, each of these has dimensions, 6 3/4 by 9, so that you'll have to consider as you think of these things and where they're going to go. This might be more residential because you're looking at very small framing to squeeze the light fixture in. Whereas if you have deeper framing, you can go with a deeper fixture. Anyway, there are so many different flavors that it's ridiculous. And of course, as I have mentioned several times, many of these light sources, compact fluorescent, some of the tungsten halogens, we're not going to be using those as downlights anymore. They are optically, particularly the halogen, are quite impressive optically, but with LEDs, I believe they're just going the way of the dinosaur. So anyway, there's any number of different kinds of trim rings that you can get on these fellows. Some incorporate lenses of various sorts or baffles, and some are more decorative than others. Again, that's a kind of aesthetic choice as to what you see. The big thing is, up in these fixtures, how much glare are you going to be willing to put up with? And there's a number of factors, including ceiling height, that's going to sort of change that calculation. Adjustable accent lights or adjustable focal light sources are very similar. Actually, this is my next plug for the Urco website. This light source is actually just a rendering from the Urco website, but I like that it's very clear, and they have this sort of rendering for all of their fixtures, which makes them very easy to understand. And all these fixtures, they can be made to fit in with a sort of recessed can grid on a ceiling. These are all aperture type of fixtures, which you can get to match. But there's this whole mechanism inside these that allow adjustability, or if they're mounted on a sort of pivot, you can also do that. And some of these are actually called eyeball fixtures, which is kind of silly. This like eyeball sticking out of the ceiling. But the idea here is that they are adjustable. They swivel around the vertical axis, but then they swivel kind of top to bottom so that you can aim them down or more sideways. And these can be ganged together into various fixtures, and some of these you can adjust them all at once, and some of them you can adjust them individually. And then one that's very common on track fixtures is what's called a gimbal ring fixture. Part of the reason these are so popular is it's basically an extremely minimal fixture. It's sort of holding a par 38 in this case, a very easily adjusted focal light source. And you can buy par 38s in different focal lengths. We talked about this when we talked about lamps. So they're really handy. They typically have snap-on features here that can control glare. This is a glare shield, but there's also a spread lens if needed to soften the light so that you don't get any bright spots. And they're obviously quite simple and cheap, and that's what we have in the Art Center. We have MR16 gimbal ring fixtures. Troffers are another type of light source you're going to see a lot of. Obviously, these are, super duper exciting, as you can imagine. These are obviously more workmanlike. The big decision you have to make is, do you want the cheapo, open look, which some people call the architectural look, especially if they're shielded with a sort of reflector. Parabolic light sources, they have very good cutoff angles. They are a little bit lossy in terms of you lose a lot of energy with those. And then the lensed fixtures are basically cheapo fixtures. These are sometimes called volumetric or up-down lights, the one here on the right. And those can be quite nice. They can also be very cheap, so you need to keep an eye on that. As we take a look at these fixtures, again, like all the others, one of the things you have to decide is what's the aperture of this fixture. Fluorescent lights are kind of standardized to typically 4-foot lengths or 8-foot lengths, so you don't have a choice going the other direction. But in this direction, you'll want to choose the overall dimension, including trim. And some fixtures have the ability to adapt to the HVAC system. They are return fixtures, so the air is sucked up through the edge of these fixtures, often through slots. Sometimes it's through the top of the fixture. Those do actually kind of self-clean, which is a nice feature. And again, it's like an ordering code. It doesn't affect the aesthetics of the fixture a whole lot. And here's a section through the one we have in the classroom, I believe. This is a fluorescent tube. This is a twin tube. Or a bent tube, a U-shaped tube, and it has a kind of a glare shield on it. Sometimes it's perforated. I think it is in our classroom. And then this giant reflector here reflects the light. So the light comes off of this light source and goes up onto the fixture. And you can imagine lights coming off of this in all directions, and it reflects off of this glare shield and up in here. And, there is kind of a lot of light bouncing around, and the glare shield does tend to collect bugs and dust. But it's a nice low glare fixture. Anyway, and then you have suspended luminaires. Typically, these are things like fluorescent lighting in corridors, and typically you want those at least 18 inches from the ceiling. Again, every manufacturer will publish data about how they should be mounted, but that's a good rule of thumb. And obviously, 80 inches off the floor, that's to keep things like kids jumping up and swinging on them. So just things to consider. And of course, the distribution of the light, you do need to really look at the manufacturer's data. You don't want these dark spots in the middle of the ceiling, typically. Again, sometimes you have situations where you do, but usually it's like a wall wash. You want an even distribution. Yeah, and there's so many different kinds of fixtures, and some have a little bit of downlight just to give them interest, and some of them have a lot of downlight and just a little uplight. Track lighting is one type of luminaire system where there are a lot of options, and it's actually great for things like retail or museums where you need a lot of adjustability. Typically, you have a lot of these gimbal ring fixtures, but also wall washers, projectors, all sorts of stuff, and they can be controlled individually and as a group. So controlling them individually is somewhat more complicated, but again, it's just a matter of specification. And that sort of thing is really handy for advanced lighting effects. Obviously, in a gallery setting, if they don't need a light, they don't dim it, they just pull it out of the track. So you really can have kind of the minimal ceiling intrusion. Finally, architectural lighting. These are coves, valences, cornices, wall brackets, and then, whatever design effects, I guess you could call them. And there's any number of different situations. For example, there's slots where you can wash a wall, and you can have a kind of row of light sources that the whole thing pivots at an angle to get you just the right angle. Or they can just glue that thing to the ceiling with a giant screw, and it just kind of creates a simpler lighting effect. Or this one is a multi focal reflector on this light source to get some really interesting effects. So this sort of thing, where these slots occur, sometimes they occur away from the wall, sometimes they occur right next to the wall. The aesthetics of where the slot occurs is one design decision, and then what do you want the light to do is another design decision. In this case, this is more grazing, this is more wall washing. And you can even have these compound reflector washing type of fixtures washing sideways up and across a ceiling. These focal reflectors, the advantage of these is that they throw light a very long ways. These types of fixtures are not as common with LED, but again, you will see them as LED advances. There are the same options for washing walls. You can just have a fixed focal angle or a fluorescent tube, which is going to throw a lot of light up in addition to down. No matter how you do these, you always need to consider the cutoff angle. This line here and this line here are the angle at which the viewer line of sight will be cut off. So if you're standing on the other side of the room, you won't be staring at a super bright par 20 lamp. And again, you can hunt around on the internet and find a million examples of all these lighting effects. And once again, with LEDs, you can sneak them in some really interesting spots. And I've seen this a million times in people's design projects, creating kind of a levitation type of effect where it is a cloud above say a lowered soffit. Very nice and simple effects. And again, they're just sneaking in fluorescent lights or LEDs, linear lights, string lights to get a different effect. And here they are kind of on a wall. And with all of these things, you absolutely do need to think in section. Here's a diagram showing the cutoff angle kind of from the entire room. You'll want to decide if it's a long throw. The throw distance is how far the light has to go. Then if it's a long throw, you're going to want to use one of these complicated fixtures that have a very strong throw and have the ability to be aimed. So anyway, other types of ceilings that you're going to run into, just a few rules of thumb. This is a luminous ceiling where you just sort of line up a lot of fluorescent lights. And again, this is the most common setting. And fluorescent tubes are still fairly popular. Again, they are efficient, and if you're not looking for great color rendering, they can be used in any number of spots for different effects. Here's a wall wash from the bottom or from the side. These kind of look silly, but that's what they are. They're in the book. Anyway, there's other miscellaneous equipment that you're going to see, including fiber-optic systems, which are really fun. They have all sorts of opportunities. And then commercial, industrial type of fixtures. Here's a gym with one type of fixture, a spot, and then here's more or less the same gym with fluorescent, linear fluorescence. These are covering large amounts of area, and you could even get these in HID light sources. These are, the types of fixtures. Sometimes people will go for an industrial look and choose these fixtures, but again, these are more about the efficiency of the light source and the durability and whatever the situation is that you are putting them in. Decorative light sources. Finally, we're getting to decorative light sources. There are so many different kinds of decorative light sources that actually this is some probably a subject for a kind of in-class exercise. The only thing that we should note here, or I want to note, is that the aesthetics of your project should govern the source of the choice of light, decorative light sources. Again, because there's so many different kinds, you'll really want a consistent look to a project. And these can be, anything from modern to, whatever, steampunk or industrial chic. The lighting should match whatever you're trying to do in your project. Anyway, the last chapter that I wanted to talk about is sustainable design. And with that chapter, actually, interesting enough, the book mainly focuses on kind of what I would call good design. And it has a number of features that are covered in other chapters, or in my case, other lectures. But the one thing that you really need to consider when you're looking at lighting is what it is luminance ratios. Basically, luminance ratios are kind of a large determinant in comfort. Anything beyond higher than the ratio recommended is going to be considered glaring. So, for example, if you're staring at a screen and it's, level 1, which is to say, I don't know, let's say it's giving off, 10 foot candles. Actually, I guess it would probably be measured in candela. But anyway, that you wouldn't want something that's 10 times as bright. It would want to be less than 10 times as bright, okay? Because that would cause glare and it would cause distraction within your visual field, all right? Your visual field is typically 30 degrees out from your eye in all directions, kind of a cone of vision. Any of these objects in that space are going to want to, they don't want to be too dark, but they also don't want to be too bright. The darker the background around, say, a workstation, the less energy you need from the workstation, because the less brightness you'll need on that screen. And actually, this is the office that Gary Gordon, the author, wrote, and he had these parabolic downlights with a kind of slight uplight feature, very low glare, really good for working on the tables. You'll notice, actually, these are old. In fact, this is my desk right here, and look at that. These are hand drawings we've got there. We've got like parallel rules and all sorts of stuff. This is old school, but anyway, the book does talk about. Kind of typical lighting layouts. Again, I'm not quite sure why this particular diagram was in the sustainability chapter, but this is a very common thing. These wall wash fixtures, you'll notice the icon for the fixture is dark on one side, light on the other. That's the standard. This is a corner wall wash, and you can also get double wall washes, which are great for corridors. These are downlights, okay? And this is a typical pattern that you'll see. If you wanted a room that has a sense of spatial quality, you can wall wash pretty continuously all the way around, and then downlights in the middle. And again, we've talked about this a couple of times. Your choice of how you want to light different things, these are paintings. You can have non-uniform illumination, and that can be quite dramatic, and you can achieve that in any number type of light sources, or you can go with uniform illumination, and again, that's typically a wall washer, but there are many flavors. That's a design decision, but your choice of luminaire, you absolutely have to make sure that the light distribution is what you're looking at first, and then try to find a luminaire that matches whatever the aesthetics of the space. There's not a whole lot of aesthetics going on in either of these spaces. The book also mentions, under sustainability, a little mysterious, but this perfect angle that lights should be mounted at. And I believe, again, it's just a matter of considering glare at all times so that you are when you have glare, people tend to fiddle around with the lights to increase the overall light level. That it reduces the glare, but it wastes a lot of energy. And there's so many different ways to save energy. Photoelectric sensors, and I think we've all been in classrooms where you have to start waving your arms around because the lights went out because of either photo sensors or motion sensors. You just need to be absolutely careful about where you put these things. Some sensors are sensing incoming daylight. Other sensors are sensing daylight in the room itself in various locations. That sort of decision is really something you're going to want to call in a specialist to help you figure out, because those are quite complicated, and sensor technology is also quite complicated, and then the whole thing needs to be dimmed or switched, and that's quite complicated. So anyway, any type of project that you're working on, there's going to be a very large load that has to do with lighting. Typically, commercial buildings, that's going to be the highest percentage because there's so much interior space. And also, depending on the region, if you're in the south of the U.S., that lighting is producing heat, which you absolutely don't want in your building. So in New England, we actually are kind of looking forward to a little bit of heat from the lighting, at least for half the year. So anyway, all of these sensors, whatever type of project you have, you'll have to consider when the building is occupied, and that will help you determine how much savings you're going to get. You can also use circuiting to save energy. So for example, in our classrooms, there are 3 different circuits for the lights. In theory, those are designed to save energy. When there's a lot of light coming in through the window, we can switch off the lights by the window. Now, that said, we don't have this exact arrangement. They've kind of randomly selected them. I'm not sure anybody was paying attention when they came up with the ceiling plan for that one. You can also do what's called split wiring of individual fixtures. So if you have a fluorescent light fixture with, say, 3 lamps, you could have 2 off and 1 on, or 2 on and 1 off, again, depending on the light sensors in different rooms. So to summarize the lecture, basically, when you choose a luminaire, the first thing you'll want to think about is, what do you want it to do? Is it a downlight, a wall wash, task, or directional? Do you want it to get attention in a space, or do you want to help emphasize some linear feature or circulation, or is it decorative? Then you want to consider what's its functionality? How does it actually work? For example, do you need a fixture that's dimmable, or adjustable, or has particularly low glare, or changes color? Then, once you've considered what you want the light to do, consider the aesthetics of the fixture. Most fixtures, even recessed ones, there are aesthetic decisions to make. Even recessed cans, you'll have to decide. You can have a white ring around those fixtures that blends in nicely with a white ceiling, but maybe you want them colored or glass or something like that. Anyway, finally, every light fixture has the potential to affect the energy usage in the building, especially when you're coordinating with daylighting. So you'll want to think about that as well.